Hi folks, Mr. Long here. We're going to do a screencast for solutions to a mastery test question. This one is on absolute value, and it's a quadratic, 2x squared minus 3x being divided by the absolute value of 2x minus 3. And what we're going to be doing is a two-sided limit. So what actually happens to this function on either side of x equals 1.5? So we're going to do 1.5 on the positive side, 1.5 on the negative side, and then finally figure out, does the limit actually exist? So does it approach the same y value coming from the left and coming from the right? So one of the things I notice right away is I see the 2 and the negative 3, the 2 and the negative 3. So I notice that probably we're going to have some common factoring here. 2x squared minus 3x, x is common, so I'm factoring out an x. So I'm left with x bracket 2x minus 3. And I am doing a limit here as x approaches 1.5 from the positive side, so that's from the right side. And what I've done is, in order to understand what version of 2x minus 3 do I use when I have an absolute value, I'm going to go all the way over to here, and you're going to see a little wee graph. And what I did is I graphed, first thing I always do is I graph 2x minus 3. It looks like this, and I put a dotted line until I get to the x-axis, because I know since it's an absolute value inside that it can't exist if it's a negative. So it only exists above the x-axis. So that's 2x minus 3. That's regular 2x minus 3. If x is less than this x-intercept, then it has to be the negative version of 2x minus 3. And in particular, what value is that? Well, it's going to be, in fact, 1.5, right? It's going to be 1.5 there. It has to be 1.5. Well, that's not a very good 1.5, but so right there, that x value there is 1.5, okay? Because that's the x-intercept for 2x minus 3. So if I'm on the right-hand side, if I'm over here on the right-hand side of 1.5, the function I'm working with is 2x minus 3. If I'm on the left side of 1.5, then I'm working with the negative of 2x minus 3. Okay, so let's go back through this. So then this version of 2x minus 3, if I'm on the positive side, is positive 2x minus 3. And what does that work out to? Well, now I've got a common factor here that I can divide out. All that I'm left with is x. And what is x approaching? 1.5, infinitely close to 1.5. So if I'm infinitely close to 1.5, really I am at 1.5. Okay, so with that limit, because I'm dividing out the 0 over 0, so I can actually reach the 1.5. Now, on the other side, let's take a look at approaching it, and I'll just highlight that, the negative side of 1.5. So I know that, again, I've got this absolute value in the bottom, and if I'm approaching from the negative side, which version of 2x minus 3 am I going to use? Well, I'm going to have to use the negative version because I'm on the negative side of 1.5. So I've got 2x minus 3 dividing out, whoops, 2x minus 3 divides out there, and all I'm left with is x divided by negative. So x divided by a negative is negative x. Oh, but I'm not dividing by 0 anymore, so I can get rid of my limit. And in fact, I've got negative of x, which is negative of 1.5. So if we look at this, the limit on the left side is 1.5. The limit on the right side is 1.5. The limit on the left side is negative 1.5. So our limit does not exist, right? So if I'm here at 1.5, that means that on the right side, I'm up here at 1.5, but on the left side, I'm down here at negative 1.5. So in fact, there's what's called a jump discontinuity. And the only thing that's left here, if you look at this, it's the graph of x, right? It's the graph of x, y equals x. So when I divide that out, so on the right side, so it's going to look like this, right? It's going to look like that. And on this side, it's going to be negative x. So negative x comes down like so, like this, right? Something like that. And it, well, except that it would be touching there. So one graph looks like this, the other graph looks like this, and there is a jump between them. That's called a jump discontinuity. Okay, so the limit on the left side is not the same as the limit on the right. Oh, and I just mixed these up again. That should say, so on the left side, 1.5, on the negative side, it was negative 1.5, and on the right side, it was positive 1.5. Okay, so the limit does not exist. Okay, hopefully that helped.